All right, let's get straight into it. If data representation has you feeling a little nervous for your exams, well, you are in exactly the right place. Today, we're going to crack the code and show you how to turn this tricky topic into some easy, guaranteed marks.
So does converting between binary, decimary, and hexadecimal just feel like a random, confusing puzzle? Do you get tripped up by negative numbers or maybe those file size calculations? Look, it's a really common struggle, but we are about to fix that right now.
In this explainer, we're going to put on a different hat. We're going to think like an examiner. We'll find the exact spots where students tend to lose marks and give you the tools to make sure that you are not one of them. So yeah, let's start thinking like an examiner and dive right in.
So here's the game plan. We'll kick things off with the absolute essentials. Then we're going to tackle the biggest traps one by one. Negative numbers, hexadecimal, those super important units, calculating file sizes, and we'll finish up with compression.
Okay, first up, let's lock in the fundamentals. Seriously, getting this stuff right is the foundation for everything else that's going to follow.
So you might be wondering, why binary? Why all the ones and zeros? Well, it all comes down to the physical hardware. A computer is just built from millions and millions of tiny little switches called transistors. And these switches can only be in one of two states, on or off. That's it. So every single piece of data, your text messages, your photos, your music, it all has to be translated into this super simple language of ones and zeros.
Right, let's get into our first major exam trap, negative numbers. This is an area where so many marks are just thrown away for no reason. But after this, I promise that is not going to be you.
And here it is, the first trap. So many students think you can just figure out the positive number and then just stick a 1 at the front to make it negative. That's a method called sign and magnitude, and I'm telling you now, it will get you 0 marks. Your exam, your syllabus, your examiner, they only accept one method, and that is 2's complement.
And forget about complicated conversions. Here is a dead simple shortcut to get it right every single time. To make a binary number negative, you start from the right-hand side. You leave every single bit the same all the way up to and including the very first one that you find. Then you just flip every other bit to the left of it. That's it. It's that easy. Now for converting a negative number back to denary, this slide right here is the most critical rule of them all. When you're dealing with 2's complement, that very first bit on the left, the most significant bit, it's not worth positive 128, it's worth negative 128. This is, without a doubt, the single biggest mistake students make. Get this right and you're already way ahead of the game. Okay, next up, hexadecimal. I know it looks a bit intimidating with that mix of numbers and letters, but it's actually your friend, I promise. We just need a reliable way to handle it, especially under exam pressure.
Listen, don't even try to do complex division or multiplication by 16 in your head during a stressful exam. Just don't. Use the binary bridge. It's foolproof. Convert your denary number to binary first, then you just group that binary string into little 4-bit chunks called nibbles, and that gives you your hex. And to go from hex back to denary, you just do the exact same thing in reverse. Easy.
And why should you care? Well, because hex is everywhere in the real world. It's used for your computer's or phone's unique MAC address. It's how colors are defined on websites. It's used for modern internet addresses. And it's also used for those cryptic memory error codes that pop up sometimes. Here's another classic mistake that examiners see year after year. Hexadecimal is base 16. That means it uses the digits 0 through 9, and then it uses the letters A through F for the values 10 all the way to 15. So if your calculation gives you a 12, the answer is C, not 12. If you write 10 or 11 in a hex column, you will lose all the marks for that question. It's a simple rule to remember. All right, this next part is completely non-negotiable. Using the wrong units is probably one of the easiest ways to throw away marks, so let's make absolutely sure you know exactly what the exam requires. Take a good look at this table. These are the IEC standard units: kibibyte, mebibyte, gibibyte. See that little by in the middle of the word? That's your clue. These are the only units your syllabus accepts, and they are all based on powers of 1024, not 1000. Let me be crystal clear here, because the examiners certainly are. If you see the word kilobyte in a question, and you use 1000 in your calculation, it's wrong. Simple as that. You must use 1024. This isn't a suggestion, it's a rule you have to follow to get the marks. So let's put that knowledge to work. Calculating image and sound file sizes is a really common exam question, and it's actually pretty easy if you just follow a simple two-step process.
Here are the formulas you need, and they both follow the same basic idea. Step 1, calculate the total number of bits. So for an image, that means you multiply its resolution, so width times height, by its color depth. For a sound file, you multiply the sample rate by the sample resolution, and then by the duration in seconds. Now, once you have that massive number of bits, you move to step 2. You just divide by 8 to get your final answer in bytes. Just burn that two-step process into your brain. Bits first, then bytes.
Okay, our final topic is compression. Examiners absolutely love to ask about the difference between the two main types, so let's make sure you have the perfect answer ready to go.
It's actually really simple. Lossy compression makes a file smaller by just throwing away data forever. You can't get it back. Think about streaming music or posting photos online. On the other hand, lossless compression is way cleverer. It finds ways to reduce the file size without losing a single bit of the original information. This means the original file can be restored perfectly, which is absolutely essential for things like text documents or software.
A fantastic example of lossless compression is run length encoding, or RLE. Instead of storing the data for a pixel like white, 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 white over and over again, it just says 10 white pixels. It stores the data value and then the number of times it repeats in a row. It's simple, but it's really effective. Okay, let's put it all together. Think of this as your last-minute cheat sheet before you walk into that exam hall. First, units like kilobyte, always use 1024. Second, hexadecimal, it's base 16, so don't forget A to F after 9. Third, negative numbers, it's always 2's complement, and that first bit is worth negative 128. And finally, be specific with your language. Don't use vague words like quality. Use proper technical terms like color depth for images or sample resolution for sound. Getting these details right is what separates a good answer from a top marks answer.
So there you have it. We've gone through all the biggest pitfalls that catch students out every single year. You now know what examiners are looking for, and just as important, you know what they penalize. So just take a second and think, now that you can think like an examiner, which one of these traps are you going to be most careful to avoid? Good luck!